This is Geometry Semester 1. It's a unit called Congruence. It's Unit 7. It's a lesson number 1 called SSS Congruence Postulate Practice. It's on creatormath.com under the Geometry tab. You might have to Google creatormath.weebly.com to find the site. The instructions are copy the following problems into your composition book on the correct pages according to the table of contents with the notes for those pages from creatormath.com. So before we get to the actual question set here, let's review, because it said make sure you're putting the notes on the proper pages, right? So let's go back and review what they're trying to tell us right there. Okay, here's the actual website, creatormath.weebly.com. Here's what the home page looks like. There it is. If you have any questions about how to fill out your comp book, you're going to go down to the words composition book and the picture of the comp book, and you're going to follow all of the video links and all of the instructions and all of the due dates, and make sure you've got your composition book filled out correctly. That's going to allow you to have a better shot at doing these problem sets in some sort of orderly fashion. Now we're going to go to the Geometry tab because that's where all the notes, the videos, the problem sets, and the vocabulary are for geometry. So first things first, this is a vocabulary geometry practice set study PDF. You're going to make sure to know how to open that, download that to your device. It is searchable, so if you're not getting 100% on your vocabulary practices, please figure out where this PDF is for all the vocabulary answers, all right? It basically gives you every definition for every geometry word we're going to use the entire school year, right? And it is searchable, so it will help you a lot. Now we're going to scroll to the semester. Make sure you got that straight. For this particular lesson we're filming right now, it's semester 1. This is the geometry table of contents. This should have been written long ago on pages 2 through 6 of your composition book. If not, go back and do it now. There are videos on how to number the pages of your comp book and examples of what a great A+ comp book looks like, so to speak, back on the home page where we just saw. So we're going to go down to the unit. This is a unit on congruence. So congruence, here's the unit. There are 1, 2, 3, 4, 5 lessons within this. First lesson is the one we're looking at, SSS Congruence Postulate. Here are the pages that these notes go on in your comp book. Please don't use this video to find those pages, but find the original table of contents because by the time you view this video, these pages will probably be different. So here are the notes. This is what you put on those pages. Fair warning, it can take a couple times to load it. This loaded the first time. If you can expand it like this, it's loaded. So here are the notes you're going to put in your comp book. It's going to talk about congruent triangles. In geometry, congruence, as you should know by now, if not, congruence means equal. So these two triangles are equal to each other, and we're going to try to figure out what that means through this unit and starting with this lesson. So this is giving us a triangle here. Notice this first one has side lengths 9, 9 radical 3, and 18. Notice this one has side lengths 9, 9 radical 3, and 18. By the way, this is 9 times the square root of 3. You can also say radical, right? Another way to say square root is radical. So we have all 3 sides of this triangle equal to all 3 sides of this triangle, or congruent as we start using. And notice the angles are the same too, and they must be for these sides to be the same length. 30 degrees, 30 degrees. 60 degrees, 60 degrees, 90 degrees, 90 degrees. So not only are all the side lengths equal, but the angles are equal too. This is called congruence in geometry. And students will often ask, why don't we just say equals? And my answer is that in geometry, we're talking about multiple aspects of equality. Not just the side lengths are equal, but the angles are too. Or vice versa. Not just are the angles equal, but the side lengths are too. There's multiple. It's not just 3 equals 3. It's a whole slew of details we're looking at. And by the way, these angles that match up and these sides that match up are called corresponding sides, corresponding angles, or corresponding locations of 2 different shapes. So we're going to talk about side, side, side congruency postulate. Given 2 triangles with the same corresponding angles, if the 3 corresponding sides are the same, then the triangles are congruent. So what we're saying here is we may see that this angle is equal to this one, this angle is equal to this one, and notice the tick mark locations, which you should know by now. This means this one's equal to this one, this one's equal to this one, this one's equal to this one, and all 3 are different from each other. Okay, we should know by now that if those three angles are equal, and the side lengths, the corresponding side lengths, the one between 1 tick mark and 2 is 10, between 1 tick mark and 2 is 10, and between 1 and 3 is 5, between 1 and 3 is 5. If those are all the same, then these two triangles can be declared congruent. All right, so we call it the SSS, which stands for side, side, side congruency postulate. These two triangles are congruent. And here's how we write it. Triangle ABC, this is a congruent symbol, and equals with a squiggly line on top of it. And these mean triangle ABC is congruent to triangle DEF. Triangle ABC is congruent to DEF. All right, so please put these notes in your comp book. They will help you do the problem sets, and I'm not going to go over all of them totally. Let's look at the next one. Are these two congruent? Why? Well, this side's equal to this one, this side's equal to this one, this side's equal to this one. Side, side, side. By the side, side, side congruency postulate, these are congruent triangles. So we can say triangle ABC is congruent to triangle DEF, and that means they're exactly the same. So let's keep going. Corresponding, we talked about already, sides or angles or parts that match up in the same location but on different shapes. Congruent, here's the symbol. This means approximately equal or, no, my bad. This symbol is for proportional or similar. It takes two of these to be approximately equal. Sorry, my brain wigged out right there. Not to scale means the drawings on the board are or on Schoology are not drawn to scale. So just because someone draws two triangles the same size, you can't declare them congruent or equal until you use one of the postulates to prove it. Put these problems in to your comp book, solve them if you can. Now let's look at the problem sets we've got. So what does congruent mean? All right off the bat, they're going to check our understanding of what these terms mean, okay? It's more than equal. It means equal corresponding angles and equal corresponding side lengths. So it's not just 3 equals 3. That's what you learned way back when. That's when we used equals. Now we're using congruent. It means more than equals. It's multiple aspects of equality that are used to demonstrate that these two shapes, in this case triangles, are exactly the same. All right, what does proportional mean? So proportional is larger or smaller by a scale factor, also called similar in geometry. All right, so you have to also start preparing for what proportional means. And remember, we've shown this model before, right? This is a scale model of a helicopter. It's a 1/43rd scale of an Augusta A109 helicopter in Coast Guard colors, right? And if you Google the real thing, an A109 Augusta, you'll see a real helicopter this full size. Well, this is a scale model, right? So that's what similar means in geometry, and it means proportional. What does proportional mean? It means similar. That's a scale model. Okay, what's the symbol for congruence? Right here. It's an equal sign with a 1 squiggly over it. What's the symbol for similarity? It is 1 squiggly line. That means similar, and remember, similar means proportional, like a scale model. Proportional, right? All right. Given the following two shapes, the following two shapes are congruent, okay? They're already telling us they're congruent. These two shapes are exactly equal, and it doesn't matter how they drew them, by the way, because remember, they could be drawn not to scale. By what congruent postulate are they congruent? So this is just warming us up on what this lesson is all about. Let's look at the side lengths. This one is equal to this one. This one is equal to this one. And this one is equal to this one. And just match the tick marks, right? 1, 2, and 3. So we have a 1, 2, 3. Notice that they go in a pattern 1, 2, 3 of A, B, C. This one goes D, E, F. I like that. So even though its orientation is upside down, if you took this and rotated it, it would exactly match up the tick marks with the corresponding sides. Okay, so this is telling us that by side, 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 all three sides are shown to be congruent to each other correspondingly. So this is side, side, side congruency postulate. That's why we can say they are congruent. All right, so, and we can write it, triangle ABC is congruent using the congruency symbol to triangle DEF. All right. All right, the following two shapes are congruent. By what congruent postulate are we using? Okay, so they're going to just keep going at it, right? And they're going to keep testing us. Now this one's interesting. Look, 1 tick mark means these two are the same length. But notice on this one too, 1 tick mark, and they're next to each other. That's good. And 2 tick marks here says this one is. So this is still side, side, side congruency postulate because we know that all three corresponding sides, in other words, rotate this way, right? Rotate it down in the same orientation as this one, and it's easy to see that this one here, well, easier to see, that these all correspond to the same locations. So we have a side, and a side, otherwise known as side, 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 congruency postulate. Now remember, postulate is a definition as opposed to a theorem, which is a proof built from postulates and definitions. Okay, just a review on that vocabulary. All right. What are they giving us here? And can I fit it all in? Barely. So the following two shapes are congruent. They're already telling us they're congruent. By what congruent postulate are they congruent? Drawing not to scale. Follow the marking. So notice they're showing us now on purpose. They drew this one smaller and this one larger. But look what the tick marks tell us. This side is exactly equal to this side, even though they're drawn different sizes. So we follow the tick marks. That's the data. That's what's telling us. Just pretend this one's, you say, how can they be different sizes? Well, pretend this one's closer to us, right? You know how something's closer to you, it looks bigger. So pretend that's the case. But in the end, they're exactly the same size. Why? Because side, side, side to side, and side to side. Side, side, side matches up with side, 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 and you rotated this, you would see its exact same order, right? So this is going to be, once again, they're sort of pushing the boundaries of what this means to use side, side, side congruency postulate. We can say that these two are congruent using the congruency symbol, these two triangles, right? All right, let's see one more. Oh, two more. The following two shapes are congruent. By what congruent postulate? All right, now they're coming at it a different way. So no tick marks, but this is 5 and this is 5. This is 7 and this is 7. And this is 12. This is 12. Are they corresponding? Well, let's rotate this, bring it down like this, and rotate it, right? Just flip it over. The D would be here, the E would be here, and the F would go to there. The DE is 5, right? The EF is 7, EF is 7, and the FD, or DF, is 12. DF is 12. Notice 5 corresponds to 5, 7 corresponds to 7, 12 corresponds to 12. Yes, by side, 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 congruency postulate, triangle ABC is congruent to triangle DEF. All right, the following two shapes are congruent. And I love this first lesson. They're really being tender with us, but they're giving us all the different ways we can sort of come up with this side, side, side congruency postulate. So it's pretty good in a short number of problems. By what congruent postulate are they congruent? Drawing not to scale. So again, we're trying to match up here ABC. Let's rotate this again like this and make this D. So the D would come here, and as you rotate it, the E would be up here, and as you rotate it, the F would be over here. Now, let's just go DE. Let's just track it out. 5, and E to F, 8, and DF, 15. DF, 15. Does that correspond? This one corresponds to this one. Good. This one corresponds to this one. And the 15 corresponds to this one. So this, again, is another example of the side, side, side congruency postulate being used to prove that these two triangles are indeed exactly the same, or congruent. Triangle ABC is congruent to triangle DEF. Okay, so that's our first lesson in congruency. I hope that helps. And just remember to match up this video title, Geometry Semester 1. It's the unit on congruency, number 7, and it's the first lesson, side, side, side congruence postulate practice, with the practice set of problems so you can make sure and have a solution to everything you're working through. All right? Hope this helps.